So now that we are hopefully feeling comfortable about what things are powers of x and how we can rewrite them, let's see the power rule. By the way, I shortened this video tremendously. I am just going to give you these rules. There is a longer video that I'll post at the end that will, if you want, you can see where these rules come from, and the math just comes straight out of limits, which is where this rule comes from. So if you'd like to see that later, you're welcome to. So here is the power rule. It's our first rule for finding derivatives. Honestly, it's not our first rule. We already found that if y equals sine of x, you should know that the derivative, y prime, is cosine of x. And we found that if y was cosine of x, then y prime was negative sine of x. So these we should know. But here is our first general rule. And this rule says that if we have x to a power and we do the derivative is equal to n times x to n minus 1. And if you look at what's going on here, it means you take what the power is and you multiply by it, and then you take that power and you decrease it by 1. Okay, so we're going to see how this works. Let's see an example. Here we have f of x equals x to the fifth. The first question to always ask yourself is this a power rule? Is this x to some power? And the answer is yes, it's x to the fifth power. Great. So can we use the power rule? Yes, and the power rule says that the way we do the derivative, f prime of x, will be we multiply by the power, so 5, and we lower the power by 1, so it becomes 4. That's 5x to the fourth. And this is the rule for what the slopes are for this function. At any x value, you can plug into this one to find what the y value is. And at any x value, you can plug in to this formula to find what the slope is. Okay, let's look at this. Try this next one. Use the power rule and find what the derivative is. If you needed some help, what we do here is we do 10 times x to the, we lower the power by 1, and it's 9. Okay, try this next one. F of x equals x squared. Well, f prime of x, we multiply by the power, and we put lower the power by 1, 2x to the 1 power. Now, we never leave it as 2x to the 1 power. We always write just 2x. So this is how we always write it if it's 2x to the 1 power. This feels really shadowy. I hope it's not too bad for you guys. All right. This next one is slightly different. It doesn't have a power on it, but the question here you should ask yourself is this x to some power? Maybe it is, maybe it isn't. Yes, this is x to the 1 power. And so the rule is that we would do 1 times x to the 0 power, and anything to the 0 power is 1. So this is 1 times 1, which is 1. And this is an important one to remember, because it seems slightly different than the other ones, but the derivative of x is just 1. And remember, this is actually a rule for the slopes of y equals x. So you guys should know from Algebra 1 that the equation y equals x is the linear parent function. And this is saying that the slope at any x value, doesn't matter what x value you're at, the slope is 1. And that should make sense. Wherever you are on this curve, the slope is 1. And so this is a formula that tells us that the slope is always 1. Okay. Number 5. Is this a power rule? Well, it sure doesn't look like it. And so you can't go making up your own rules, except that in our warm-up, we learned that we could rewrite this as a power of x. What power of x is the square root of x? Well, the square root of x is x to the 1/2 power. Remember that roots, the square root is automatically a root of 2, and roots go in the denominator, and it's x to the 1 power, so that goes on the top. So now that it's written as a power, we can do the derivative. I want you to pay very close attention to my labeling here. Always up here I put f prime, f prime, f prime. This is not f prime yet. This is not the slopes. This is literally the same thing, just rewritten. I rewrote it. These mean the same thing. I have not done the power rule. I have not taken the derivative yet. I was just rewriting it. And now I will take the derivative. And the power rule says I multiply times by the power, and I lower the power by 1. Now, I'm going to do this off to the side here. 1/2 minus 1. These you can't combine until they have the same denominator. And there's a really easy trick you can do when you're subtracting 1, which is you just choose whatever the denominator is a minus. You choose whatever the denominator is, and to make it 1, it's the same number divided by the same number. So like 2 divided by 2 is 1. If this denominator had been 5, I would subtract 5/5, because subtracting 1 is the same as subtracting 5/5. Now that they have a common denominator, I can subtract 1/2 minus 2/2 is -1/2. And so this will be x to the -1/2 power. I subtracted 1 there. So hopefully we feel good about those fraction skills. The last thing we do is, if this was written as a root originally, we are going to rewrite it as a root. So we need to know what x to the -1/2 power means. And we know that x to the -1/2 power means that we're dividing, and so it's going to go in the denominator with the 2. So 1 is in the numerator, 2 is in the denominator, and then this is going to be in the denominator as well because of this negative exponent. And x to the 1/2 power is the square root of x. So the slope formula for the square root of x is 1 divided by 2 times the square root of x. This one we will eventually memorize because we use it so often, it comes up a lot. Okay, try this one on your own. What is the derivative here? And hopefully you were able to do it, but if not, that's okay. We want to start by rewriting this as a power of x, because right now we can't use the power rule because it's not a power of x. So this is still f of x equals, I have not taken the derivative, this is still the original function, and a cube root is a fraction power of x. The root part goes in the denominator. This is the 1/3 power of x, and then we're going to do the derivative. We multiply by the power, that's what the power rule says, and we lower the power by 1. So to lower it by 1, we're going to subtract 1, and the easiest way to subtract this is by making the special form of 1 that we want is 3/3. 3 divided by 3 is 1, but now they have a common denominator. 1/3 minus 3/3 is -2/3. So this is going to be x to the -2/3 power. Again, it's a negative exponent. And so it's going to go down to the denominator. You'll only put it in the denominator if it's a negative exponent. 3 to, this is going to be a root because it's a fraction exponent. It's the cube root of x squared because of this numerator being a 2. Notice that the top part of the fraction stays on top and the bottom of the fraction is going to be the denominator with the multiplication. A special thing I want to point out here is that it's pretty easy to check yourself to make sure you didn't get them backwards by seeing, is this root the same as the root in the answer? It'll always be the same. So if it's square root, it'll always be square root here. Now this power can change, but the root part will be the same. That's a good little check on yourself. Okay, try this one on your own. One more of these ones. And so we're going to do finding f prime of x. Hopefully you're able to get it, but if not, we want to start by rewriting this. This is f of x, notice I have not put f prime of x yet, is equal to x to what power? Well, the cube root is in the denominator, and the squared goes in the numerator, so x to the 2/3 power. The derivative, the power rule says we multiply by 2/3, and then we are going to lower the power by 1. So 2/3 minus 3/3 is -1/3, and to rewrite this, we would put 2/3, and then in the denominator, because of this negative exponent, we would put the cube root of x. And it's x to the 1, we don't have to put the x to the 1. So 2 over 3 cube root of x. Now guys, really quickly, I want to point out, I sometimes see this where kids get used to these things going into the denominator. It only goes into the denominator if it at the end it has a negative exponent. These all had a negative exponent. And let me give you another example that's not one of these ones here. I don't know why I haven't changed this over the years. I should have. Let's do the square root of x to the 5th. And we're going to put y equals square root of x to the 5th. Y equals square root of x to the 5th. Go ahead and try this one. This is, we're going to rewrite it. This is x to the, it's the square root, so 2 in the denominator. X to the 5/2 power. Now we're going to take the derivative. Notice it was not the derivative until I actually do the power rule. We're going to multiply by 5/2, and we're going to lower the power by 1. So 5/2 minus 2/2 is x to the 3/2 power. Now be a little careful here. This is not going to go to the denominator because this is not a negative exponent. Instead, we're going to have 5/2 as the coefficient. And we're just going to multiply it off to the side. You could put it in the numerator and it wouldn't be wrong, but it's not how we usually write it stylistically. We usually put square root of x cubed, and the cubed can go either inside or outside of the root. One more thing I'd like to show you is, this is just a stylistic thing. If the problem starts with like y equals x to the 3/4 power, okay, we will not have to rewrite it at the end. We can just leave it in fraction. So if they give you the problem like this without it simplified with a fraction exponent, you can leave a fraction exponent at the end. So y prime, it's already ready. It's as a power. It's 3/4 x to the 3/4 minus 4/4 is -1/4. And because they didn't rewrite the power at the beginning, it's kind of okay to leave it like this at the end. Okay, so if it's not written as a square root at the beginning, you don't need to write it as a square root at the end. Okay, this last one, go ahead and try it on your own. What's a little bit different about this? Is this a power? Not yet. It's dividing, and there is a dividing rule, but it's tricky and hard. It's not what you might think it would be. And so instead we want to rewrite this as a power. 1 over x is x to the -1 power. And so the derivative is going to be, we multiply by -1, and we lower the power. And so we're going to do -1 minus 1, which is -2. When you have a negative power and you lower it, it's going to become an even lower negative. And because it was not written as an exponent at the beginning, we'll rewrite this. This is a negative exponent. It will go to the denominator. So -1 over x squared. So hopefully we feel okay about that. Why don't you guys try this one on your own? And the first step, of course, is to rewrite it. This is x to the -2 power because it's dividing. And so we can, this is not a power of x right now, but we can rewrite it as a power of x. And now we can take the derivative. We're going to multiply by the power and lower the power by 1. -2 minus 1 is -3. So it's x to the -3rd power. And finally, we can rewrite this as -2 divided by x cubed because of that negative exponent. How bad is this shadow? It's okay. Okay, great. The other thing I want to point out is sometimes kids will try to make up their own rule. They'll be like, oh, x squared, I can do the power rule on that. The power rule is you multiply by 2, and lower the exponent by 1, and I'll just leave it in the denominator and get 1 over 2x. Well, can you do that? Did that come out to be the right answer? No, it didn't. You do not get to make up your own rules. You can only use the power rule. You can't use the power rule if the power rule shows up in the middle of some problem somewhere. You can only do it if it's 1 over x to the n, you can't use the power rule. The power rule is only if the thing can literally be rewritten as x to the n. This is when you can use the power rule. So be a little careful. Okay, how about this next one? Is this a power? What is the power of n that lets us do it? Well, this is x to the -4th power, and so we can do the power rule. So find the derivative. We want to multiply by the power and lower the power by 1. -4 minus 1 is -5, and so here's our answer. We're going to rewrite it as -4 over x to the 5th. This next one, how do we rewrite this as a power? This is x to the negative power because it's 1 over, and it's a fraction power because it's got a root. This is the 1/2 power. It's a square root, so that's automatically a 2, and it's x to the 1. So what is the derivative? Well, we will multiply by the power, -1/2 times x to the, we need to lower the power by 1. We have -1/2. We're going to subtract 2 halves, because that's subtracting 1. -1 minus 2 is -3 halves. So this is x to the -3 halves power. And we can rewrite this as -1. This is now a negative exponent, so it needs to go to the denominator. The square root of x cubed. And the cubed could go inside. That would be correct also. That would be fine. Okay, the last one is another special case. Is this a power of x? Well, it's x to the 0 power. There aren't any x's here. X to the 0 is 1. And when you multiply by 0, the derivative will always be 0. I'd also like to point out that, remember, this is just a slope formula. And so if you have f of x equals 8, y equals 8, that is a horizontal line. And so what's the formula for the slope anywhere? Well, the slope here is 0, and the slope here is 0, and the slope is always 0 for a horizontal line. So whenever you have a constant, so like y equals 15, or y equals 208, or even something like y equals pi or y equals e, these are constants. They're not variables, they're changing. Pi is like 3.14 about, e is 2.718 ... These are constants, and they're not changing. And so even though they might look tricky, the derivative of all of these is 0, because even if you have something like y equals pi or y equals e, you're just saying, okay, y equals e, the y value is always e, and so the slope will always be 0. So watch out for constants. They're easy, but they are slightly different, and you'll get used to them very quickly. All right, so let's make sure we all feel comfortable about what are things we can do the power rule on. I'm going to give you guys a chance to sort some of these and make sure you feel good about which ones are power rule ones and which ones are not. Let's learn a new rule, the constant multiple rule. The constant multiple rule works exactly like you would want it to work. Notice it is different from when there's just y equals a constant. The derivative of a constant was 0. The derivative of this will not be 0. When you have the derivative of a constant times some function you know, the derivative is that constant times the derivative of the function you knew. So I want to give just a couple of examples before I let you practice some on your own. One example will be y equals 7 sine of x. This is a constant times a function we're supposed to know the derivative of. And if you haven't memorized it yet, it's time to memorize it. The derivative of this is going to be the constant multiplier rule. Since there's no plus or minus in between here, these are multiplying. The constant multiplier says you leave the constant alone and then do the derivative of the function that you normally, that you should already know. And the derivative of sine of x is cosine of x. So the derivative of 7 sine of x is 7 cosine of x. And this is kind of what you would want the rule to be anyway. Most kids do not have any trouble with it. One more example is y equals, let's do 5x to the 10th power. Okay, so 5x to the 10th power. Here's our constant. It is multiplying times x to the 10th. And so the rule says when you do the derivative, you leave the constant alone and you multiply by the derivative of the thing you know. And we know this derivative because it is power rule. The derivative of x to the 10th is 10x to the 9th, and now you can actually multiply these together. And we get 50x to the 9th power. Almost everybody will skip this middle step and just say, look, with the power rule ones, I know this power will just end up multiplying times this constant because the constant's still going to be there when we multiply. So 10 times 5 is 50, x to the 9th. So you multiply the constant times whatever's there and lower the power. Okay, let's see how you guys do on this. Let's try f of x equals 3x squared. If you weren't able to get it, let's look at it. F prime of x, we're going to leave the constant alone and multiply by the derivative of x squared. That's power rule. This is x to a power. So we know how to do it. It's multiply by the power and lower the power by 1, which is just x. We don't write x to the 1 power, it's just x. I guess I could write it if you want, but I'm going to simplify it in a second. And then we can do 3 times 2, which is 6, and x to the 1 is x. So 6x. Almost always people will go straight from here to here. So the derivative of 3x squared is 6x. And again, so here's this parabola, y equals 3x squared. This f prime equals 6x is a formula for what the slope is at any point. When x is 1, the y value is 3. There's this point 1, 3. That's coming from here. What's the slope when x is 1? Well, the slope is of this tangent line is 6, because when x is 1, f prime of 1 is 6. And so it's telling us the slope of the curved line. On different parts of the graph, like if we did f prime of -1, that's saying what's the slope at -1? And when x is -1, the slope is -6. If I plug in -1 here, I would get -6, and that's the slope. Even though when x is -1, the y value is still 3, the slope value is -6. So that's what these slope formulas are telling us. Okay, how about this one? This doesn't look like a constant multiplier, but it is. remember that x to the negative fourth we can rewrite as x dividing by x to the fourth we can rewrite as x to the negative fourth. So this is 2 times x to the negative fourth. The 2 is in the numerator, and so it's still going to be multiplying on the top. So 2 times x to the negative fourth. If this had been, this is something that throws some kids off, if this had been like 2 over 3x to the fourth, the constant multiplier is 2/3. This would be 2/3 times x to the negative fourth. The 2/3 is a constant, and the x to the negative fourth. Don't try to mess around with like this being 3 to the negative 1 or negative 3 or something weird like that. 2/3 is the constant. Okay, so go ahead and do this. Hopefully we saw that we can multiply by the power. So f prime of x equals -8. X to the, we can lower the power down by 1. -4 minus 1 is -5. And so we need to rewrite this at the end. So this is -8 divided by x to the 5th power. Okay. Try this next one on your own, see how you do. What is the derivative? And the first thing we're going to do is we're going to rewrite this. And we're going to be a little careful. We're not writing f prime yet. We're rewriting this as a power of x. So it's getting divided. The 2 is going to still be a multiplier. 2 times, this is x to what power? Well, it's dividing, so it's a negative power. And it's a root, so it's the 1/2 power, -1/2 power. We're going to multiply, so f prime of x equals 2 times 1/2. I hope we feel good that multiplying by 2 and dividing by 2 cancel out, and so we just get -1. So we get -1, x to the, we need to lower the power by 1, so we're going to subtract 2 halves. This is a fancy form of writing 1. -1/2 minus 2 halves, -1 minus 2 is -3 halves. We need to rewrite this. This is -1 over, we know it's dividing by because it's a negative power. This is over the square root of x cubed. So -1 over the square root of x cubed. All right, last one for you guys to try on your own before we get to a new rule. Here, we've got these dividing. Let's see how we did. First, we can actually like simplify 6/4 as we rewrite this. So this is divide by 2, divide by 2. This is 3 halves is the constant multiplier. And this is going to be x to the -2 because we were dividing by x squared. So we're going to multiply by -2. And multiplying and dividing cancel each other out. If they hadn't canceled it out, let's say we had left it as 6/4, we would have done 6/4 times -2. And the way you multiply by a whole number is you just put it over 1. -2 over 1 is -2, and you could just multiply straight across, and you would have gotten -12/4. But now we actually have a slightly easier shortcut, which is multiplying by 2 and dividing by 2 will cancel out. And so we'll get f prime of x equals 3 halves times -2 is -3, because multiplying by 2 and dividing by 2 cancel out, but a positive times a negative is a negative. And we need to lower the power by 1. This is x to the -3rd power, because -2 minus 1 is -3. This is a negative exponent, and so we need to rewrite it as -3 over x cubed. Okay, so the next rule we're going to learn, and again, guys, all 3 of these rules, there's a much longer video available to you at the end if you would like to see where these rules come from. Maybe it'll be a bonus question on your test, how to actually derive these, is the sum and difference rule. And this works. This is the last derivative rule that makes sense. After this, they get nuts. But this one says that if you're trying to do the derivative of 2 or more functions adding together or subtracting, you just do the derivative of each one separately. That's exactly what you would want to do. So you don't have to like do anything weird or fancy. You just like do the derivative of this one, do the derivative of this one, and if it was adding, you keep it adding. If it was subtracting, you keep it subtracting. And so let's just like very quickly look at an example before I let you try it on your own. Let's say we have y equals x to the 3rd plus cosine. Let's do 2x to the 3rd plus 3 cosine of x. Okay. This is 2 things adding. And the key thing here is this, I'm going to rewrite this, this got messy. These are considered separate terms adding together. And so you can treat them like different functions and do them each separately. When you do the derivative, we're just going to do the derivative of this function. This is a constant multiplier times x cubed. And so we leave the constant multiplier alone and do the derivative of x cubed. we multiply by the power, lower the power by 1, and here we also have a constant multiplier. We have a multiplier of 3, and it's multiplying times cosine of x. What is the derivative of cosine of x? Hopefully we all know it's negative sine of x. So we're going to leave the constant multiplier alone and multiply times negative sine of x. This parentheses is important here. If I didn't have the parentheses, this would not say 3 times negative sine of x. It would say 3 minus sine of x. This is good. This is wrong. And when we multiply a positive times a negative, we'll change this to a subtracting. So positive 3 times negative sine of x is negative 3 sine of x. And this is how we would write it. And a lot of times people will just jump. They'll be like, oh, aha, the derivative of cosine is going to be negative sine, so I know I'm going to have to change this sign here. If it was like minus 3 cosine of x, when you do the derivative, it'll become plus 3 sine of x, because negative 3 times negative sine of x is positive 3 sine of x. So just be aware. All right, let's see how you guys do on your own. What is the derivative of f of x equals x cubed minus 4x plus 5? Well, we don't need to rewrite anything, so I'm just going to go straight into the derivative. This is a power rule. It's 3 times x, and we lower the power by 1. So we multiply by the power and lower the power by 1. This is negative 4 times x, and remember that the derivative of x was kind of a special one. X is x to the 1 power, and you just want to remember that the derivative of x is just 1. So the derivative of 4x is 4 times 1. And so this is minus 4. Whenever you have something x, it'll just be the constant in front of it. So the derivative of 7x is 7. The derivative of 50x is 50. And this is also kind of a special one. What is the derivative of 5? Well, that's a constant. And the derivative of all constants is 0. And so this is the derivative, 3x squared minus 4. Okay, let's look at this next one. What is the derivative? There's nothing that needs to be rewritten because there's no funny powers. So this is a power rule one, constant multiplier times a power rule. So we're going to get negative 6x squared. Here we have a constant multiplier times a power. So multiply by the power, lower the power by 1, which is just x now. X to the 1 is always just x. The derivative of cosine x is minus sine of x. The derivative of cosine is negative sine of x. And this is a constant multiplier times sine of x, and the derivative of sine of x is cosine of x. Okay. Last one. Let's see how you do. Hopefully these are feeling easier and easier for you, and you feel good about it after this one. We do have a mastery quiz coming up really soon. I believe next class. Hopefully I'll tell you about that at the beginning of class when I'm actually presenting this lesson. But we have a mastery quiz coming up on basic derivatives using these 3 rules, as well as the sine and cosine. That's it. Not a lot on it. The trickiest thing is like the fraction ones and rewriting them. So here there's nothing to rewrite, so we can just go ahead and do it. This is 12x cubed. We multiply by the power, lower the power by 1. Multiply by the power, lower the power by 1. Multiply by the power, lower the power by 1, which is just x now. And the derivative of negative 5, this is a constant, becomes 0. That's it. Let's now go look at some of the more tricky ways that they can show up, that you might need to use these rules by doing a little bit of extra math.